Next topic that we have to do, that is differentiation. Now first of all, what is differentiation meaning is? Differentiation or derivative. This actually represent change of a variable with respect to other variable. Most of time this is dependent variable and this is independent variable. Suppose we say y is equals to 5x square plus 2. So x is independent variable, y is dependent variable. So if we want to find what's the change happening in y with respect to x, then we can write it as dy by dx. So this is called differentiation of y with respect to x, because y is a function of x. Y is a function of x because y is equals to what? Fx. As function is quite clear to you. Y is a function of x, so y is equals to fx. So if we want to find out what change is occurring in y with respect to x, then we can write it as dy by dx. So the symbol of differentiation is dy by dx. Suppose if I want to find out change in y with respect to z, this is change c. Change in y with respect to z, then we can write it as dy by dz. If we want to find change in x with respect to y, then we can write it as dx by dy. So differentiation actually represents the change occurring in one quantity or a variable with respect to the other variable or a quantity. If we have a constant, say y is equals to 5. Here y is equals to 5 means y is a constant value. If we having x is equals to 0, 1, 2, 3, so on. And if I find dy by dx here, y is not a variable, y is equals to 5 is a constant here because it has a fixed value. So y is not going to change with x. If we have x is equals to 0, even then y is 5. If we have x equals to 1, for that also y is equals to 5. If we have x is equals to 2, y is also again going to be 5. So y is not changing with respect to x. So y is a constant here. So is there any change of y with respect to x? No. For that we have a derivative equals to 0. This is the formula of derivative. As we discuss further more formula related to it. But now I wanted to discuss with you in detail about what is differentiation actually. So I hope the symbol of derivative is clear to you all. What's its symbol? Now why only this symbol? What's the meaning of this symbol? For the change, we have 2 to 3 symbols, say delta this, and t. This also is symbol of change. This is also a symbol of change. This is also a symbol of change. This means small change. If I say delta x means small change in x, small change in x. But d means very small change, very small change, or we can also call infinitesimal change, means very quite small change we can also say. So why we have this symbol? If you remind about the function, in function we did when limit of x approaches to a, then function tends to a particular value, say f. Or if we say if there is a change in y with respect to x and this x approaches to 0, means change in x is very small, it's almost 0, not 0 exactly but almost 0. In that case, with limit delta y by delta x, this complete symbol changes to dy by dx. Why so? Because if this change is quite small, this means change in y is also very, very small. Means this change is, if this change is very small, then it's going to be converted in this symbol d. So derivative, it's actually a result of function with very, very small value of limit. So now let's read its define. The differential coefficient of derivative of variable with respect to x is defined as instantaneous change of rate of y with respect to x. Means change of y with respect to x. So what y is changing or how much y is changing with respect to x. If we say y is a function of x, y is a function of x. Now, for the sake of example, we consider y is a function of x. Let x be independent variable and y be dependent variable. Therefore, by changing x, we get a change in y, of course, that is quite obvious. If we change the value of x as y is dependent upon x, if change occur in x, then change also occur in y. Suppose value of x increase by small amount delta x. So corresponding, the value of y also increase by delta y. So if we say y increases to y plus delta y and function is going to be x plus delta x, then what's the change happened? Change in y, delta y. We have to find this change. Means new value is y plus delta y. Previous value was y. If we subtract this, y get cancelled with z. So delta y is what? Fx plus delta x minus fx. I substitute the value of this and this. So if we divide this both side, this and this side with delta x, means we are going to encounter the change with respect to x. So we can say delta y by delta x is average change in function of x with respect to y, or if this change is instantaneous. Instantaneous means delta x approaches to very, very small, that is 0. In that case, with the limit delta y by delta x approaches to 0, this also on this side limit is 0, this side is going to be dy by dx. This is one form of derivative. So geometrical interpretation, if we represent this with geometry, suppose if we have a curve, this is a graph, on this side we have x-axis, on this side we have y-axis, and this is origin. We have a curve, say this type of curve, and we consider 2 points of on curve P and Q. Line joining this is acting as a chord of this curve. This is acting as a chord for this curve. So if we extend this chord, let this chord make an angle alpha with x-axis, positive x-axis, it's making an, or with x-axis making an angle alpha, this chord is making. So x-axis, y-axis, origin, curve, P, Q, chord making an angle of alpha. Now I draw a line. It's not so clear. Let me draw it more perfectly for you all. Q dash. Let this point be S, this point be E, or whatever you want to take this point. As if we take this value as x and this value is x plus delta x, then this value PS, it's going to be delta x. If we say this value is y and this value is y plus delta y, this complete value is y plus delta y, this value is y, then this value is what? Delta y. Then QS is delta y. QS delta y. ps delta x. So we get this. So if we say about the slope, slope is equals to what? Slope is equals to this by ps, or we can say tan alpha, because we have a formula for the slope, tan theta. Here theta is alpha, and other formula is del change in y by change in x. So we get tan alpha is equals to delta y by delta x, where delta y is what? If we if I add this term with y and subtract it with y, this becomes this term, where y plus delta y is a function of x plus delta x, and y is a function of x only. So again we get the same formula by plotting the curve. Now if we are going to do what? If we start compressing this slope or moving the point q toward p, this is point q, we are starting moving toward p. What we observe? If we move it toward it, then this distance between them, delta x, it will start decreasing. It will start decreasing. And this distance, delta y, if point q is here, then this is delta x and this is delta y. So what we observe? With decrease of delta x, delta y is also decreasing. And as q approaches to p, means at here, if p and q almost coincide, it means delta x approaches to what? 0, means this change is very very small. In that case, this change will become instantaneous change, that will become delta dy by dx. So this is the geometrical form of derivative. Now next, there are few formula. If we take derivative of a constant, as constant do not change, so it changes 0. If we take derivative of y, where y is equals to cx, derivative dx of cx, where c is a constant, x is a variable. So we always have to take, if constant is in multiple with the variable, then we have to take constant outside the derivative. Inside we get dx by dx, cancel with this, so we get only c. If we have y is equals to cu, and we have to take derivative with respect to x, so what we get? D by dx, instead of y we write cu. Again, c is a constant taking outside, but u is a variable, so keep it inside, because u is a function of x, we don't know what's the value of u, so we just keep it inside like this. If we know the value of u, we substitute it, and after that we solve it. There's another formula. If we have derivative of x raised to power n with respect to x, then its formula is what? We have to take power outside and its power reduced by 1, xn minus 1. Then again we have derivative of the base. This is x raised to power n. This is base. This is power. First step, we have to take power outside as such. Then second step, base with power but 1 less, xn minus 1. And again d by dx of base. Base is here, dx again. So dx get cancelled, we get result n x raised to power n minus 1. Similarly, if I take derivative of u with respect to x, where u is a function of x, then we are getting what? Is say un with respect to x, where u is a function of x, then dx u raised to power n. Again, as u is a function of x, means u is not a constant here. Power first, then u with the 1 power minus, then again derivative of what? Base, that is u. Let me clear it more to you with an example. Suppose I have 5, or sorry, if I have x raised to power 9. Find its derivative with respect to x. Then dx raised to power 9 by dx. This is going to be power, first of all in front power, then x raised to power with 1 power less, that is now 8. Again derivative of base. Base is here x. So dx is same, so it get cancel 1. So we get 9x raised to power 8. Now if I have 5 raised to power 5. 5 is a constant. Its raised to power 5 is also going to be a constant. So derivative of a constant, we get what? Again, its derivative with respect to x I am taking. d by dx of 5 raised to power 5. Again applying formula 5 front with 5 1 power less, that is 4, and again derivative of base. Base is here 5 now by dx. Now 5 is constant with respect to x, so its derivative is 0. So 0 into something is 0. So its result is going to be 0. Suppose I have a term 5x raised to power 10. We take derivative of this with respect to x. 5x raised to power 10. 5 is a constant and it's in multiple with the variable, so we take it outside the derivative. We inside left with x raised to power 10. So 5 into 10 x raised to power 9 into dx by dx get cancelled. We get 5 into 10 50 x raised to power 9. So this is the use of formulas. Next, again if we have u raised to power n, where again u is a function of x, we have to find its derivative with respect to x. Then d by dx u raised to power n, again n front u n minus 1, and we have to take derivative of u with respect to x. Here u is not a constant, u is a function of x, so we keep it as, by substituting the value of u later, if we know the value of u, we get this value. Suppose u is 6x. If we substitute the value and instead of u, we can write 6x n minus 1 into d by dx into 6x. For 6 is a constant, we will take outside, and u, oh sorry, this is 6x raised to power n minus 1 into 6 into dx by dx. This is going to be cancelled. So we get the result 6n 6x raised to power n minus 1. So if we have two terms u plus v, say question is y is equals to 5x square plus 2x. We have to apply linear operation. If we take derivative on both sides with respect to x, then this derivative get multiplied with this and this too also. So we can write d by dx of 5x square plus d by dx of 2x. So 5 is a constant, taking outside, dx square by x by again applying the formula, plus 2 is a constant, taking outside, dx by x. This cancel it. So this is 2x, 5 into 2 into x raised to power 1 into dx by dx plus 2 cancel. We get 10x plus 2. If I write nothing here, means it's power 1. So it's a property of linear operation here. If we have two terms in multiplication, this means what? Sorry for this. Two terms in multiplication means if I have u into v, then we are going to apply formula u as such derivative of v plus v as such derivative of u. Like if I have x cube into e raised to power x. Now, let me tell you one thing, e raised to power x derivative. If I take derivative of e raised to power x as such, with inside derivation, here we take derivation of power. Power is x, so dx. So suppose if I have derivative of e raised to power 5x, then it's e raised to power 5x into derivative of 5x, which is 5 again. So e raised to power 5x into 5 into dx by dx get cancelled with each other. So we get 5 e raised to power 5x. So for y is equals to x cube into ex. This is u, this is v. So first u as such derivative of v plus v as such derivative of u. So we get x cube into e raised to power x plus e raised to power x as such, because derivative of e raised to power x is e raised to power x. Of this is 3x square. Now I think so you are able to solve it by yourself this time. Next, if we have u by v, like if y is equals to 5x plus 2 by 3x. Suppose this complete term is what? U. This complete term is what? V. Then we have to apply formula v derivative of u with respect to x minus u derivative of v with respect to x upon v square. So I apply this formula to this. So I get dy by dx is equals to, here u is 5x plus 2 or v is say 3x. This by this, so this is the first v as such means 3x as such. We have to take derivative of 5x plus 2 minus then 5x plus 2 as such. We have to take derivative of v, that is 3x, upon v square. V is this 3x whole square. Now again applying linear operation here, this into this means derivative of this and this, alternatively we get 3x d by dx of 5x plus d by dx of 2 minus 5x plus 2, and derivative of this 3x is only 3 by solving it, upon 3x square. If we solve this, derivative of constant is always 0. Derivative of 5x is 5. So we get 3x, inside we get 5 plus 0 minus 5x plus 2 into 3 upon 3x plus 2 whole square. So after solving get 15x minus 15x plus 6 upon 9x square. If I open the bracket, this of become negative and this is also of negative. So cancel with each other. This is also going to be negative. We get minus 6 by 9x square. This is 2, this is 3. 2 by 3 with the minus sign upon x square. So we get an answer of minus 2 by 3 x square in last. So in this way you can solve u by v term. So for now you need to do this quite complicated. You will do a chapter related to differentiation in plus 2 maths. Then there are some derivative of trigonometric terms. If y is equals to sin x, then derivative of sin x is always cos x. If derivative of, we have y equals to cos x, derivative of cos x is minus sin x. Similarly, there are other trigonometric formulas, you have to learn this. Derivative of y is equals to ex, we already done this. This is always ex. Y is equals to a raised to power x, again e raised to power ax as such. Then derivative of ax, we get only a here, so aex. And derivative of log, when I will discuss about you about log in with you about log in detail, then I will tell you also the derivative of log term, because first we have to do about the log in quite detail, because log is a very important mathematical tool that is required. Log and log, differentiation, integration, vector, these are the tools that you not reluct, because you have to use it again and again in each and every part of your physics. So for right now, no need to do this maxima and minima. I will discuss with you if we encounter any question related to this. But let me tell you one thing, double derivative and triple derivative. This dy by dx is called single derivative of y with respect to x. If we again take the derivative of this with respect to x, then we can write it as d square y by dx square. This is called double derivative. This is called double derivative. If we take the derivative of double derivative, if I'm going to again take of derivative of this term, Then it can be written as d cube x upon d cube y upon dx cube. So this is third derivative. So similarly, we have fourth, fifth, and so on derivative of it. With this part of derivative